Hi everyone. Today we're going to start our unit on Combinatorics, which is a heavy math word to say the math of counting things. So this is going to lead us into conversations about probability and how many options for different things there are. Today we're specifically going to talk about permutations, but by the end of this video you should be able to classify a situation as a permutation or a combination, and you should be able to calculate permutations. So I said these words a lot, but you're probably wondering what a permutation and a combination are. So let's talk about that first before we get into some problems. So a permutation and a combination are both a way of counting things. Now, more specifically, if you Google it, you'll see the definition is more of like a way in which a set of, or a number. A way in which a set or a number of things can be counted. Maybe I won't use the word counted. Maybe I'll say ordered or arranged. Okay, so a permutation and combination is a way to count how many different ways a set of things can be arranged. Now, a permutation and combination are slightly different ways of counting things. So permutation you would use if order matters. And by contrast, a combination is what you would use when order does not matter. And this will make more sense with more examples, so just bear with me. Just get these notes down for now. I saw one way to remember permutation is when you see P, think position. And again, this will all make way more sense with some examples, but I want you to have the definitions down. Now, there are multiple types of permutations or combinations, but we'll just leave it at that for now, and then when we look at more examples, we can go back. Okay, so the first set of problems, we're going to decide which one is a permutation, which one's a combination. So the first example is an example of a permutation or combination. It's saying how many different ways can you award first place, second place, and third place prizes among 8 contestants. So that'd be like, how can I arrange a gold, silver, and a bronze medal among 8 contestants? And this would be an example of a permutation. The reason this is an example of a permutation is because order matters. Getting first place is totally different than getting third place, right? Like, you're going to go for the gold, you wouldn't be as happy with the bronze. Or silver is different than bronze. So that's why order matters. Whereas if you're doing something like, this is an example that's similar. How many ways can you pick the top 3 finalists from a group of 8, right? Similar problem, different though. This is a combination because order doesn't matter. So like if you are on The Voice, the TV show, and you want to be a top 3 finalist, it doesn't matter if you come first place, second place, or third place this time because all 3 finalists will move forward. So in that case, order does not matter, which is why it would be a combination. So if you compare and contrast the first and the fourth, you can kind of see the difference. So next 2, how many ways can you pick a team of 3 people from a group of 10? And this is again a combination because it doesn't matter who the team is. It can be Jack, Sasha, and Trevor, or it can be Sasha, Jack, and Trevor. It doesn't matter the order. It's just a team of 3 people. Whereas the second one says how many ways can you pick a president, a vice president, and a water boy from a group of 10 would be a permutation because the order matters. The person who's the president is different than being the water boy, is different than being the vice president. Again, so you can compare and contrast these two to kind of see the difference between a permutation or a combination. So I kind of hope that clears up what permutation and combinations are in general. So it's a way in which we count how many things can be arranged. So like I'm counting how many different ways can 8 contestants be put in a first, second, and third place. Whereas a permutation, order matters. So first, second, third is different than third and second. And in a combination, order doesn't matter. So I just pick a top 3. Now, the main point of today is to learn how to actually count these things. So how can you answer a question such as this? A license plate in some state must have 2 different letters followed by 4 digits. The first digit cannot be 0, but digits can be repeated. How many different license plates are possible? So this is what Combinatorics does for us. It helps you count things. How many license plates are possible? That's you're counting how many ways you can make a license plate. So you first may want to decide, is this a permutation or combination? And hopefully you're thinking permutation because order matters. A license plate that has the first 2 letters as AR is different than a license plate that has the 2 first letters of RA. or of PQ, whatever it may be. So order definitely matters. This is a permutation. And for this video, we're going to only be talking about how to calculate permutations. Okay, that's why we'll be studying how to calculate permutations as our objective. Okay, now that you know it's a permutation, let's talk about how you calculate this. So you're talking about a license plate. I just like to set up the scenario. So a license plate is an order of letters and numbers. And this one particularly says it has 2 letters to start. So this has to be a letter, this has to be a letter, if I'm like drawing the positions of the license plate. And then it's followed by 4 digits. 1, 2, 3, 4. So these are all digits, or you can write number, whatever you want to write there. Maybe I should write number signs. Okay, so that's how many different places there are for this license plate. I always say my first step of a permutation is to set up like my blanks. And my blanks are just like placeholders for what could go in that blank. Now the tricky part is, what do I fill into these blanks, right? So the first one has to be a letter and the second one has to be a letter. But it also says they have to be 2 different letters. Now there are 26 letters in the alphabet. Okay, so that means there are 26 options of things that I could put into this first place. I could put A, B, C, D, E, F, G there, so on and so forth. So there are 26 different options to go in space 1. Now it says there are 2 different letters. So let's say I pick A to go here. Then our second blank cannot be A because they have to be 2 different letters. So that means there are only 25 different options for blank 2. Okay, so 26 options for blank 1, 25 options for blank 2. Now 4 digits are the next blanks. How many digits are there? There's 0, 1, 2, all the way up to 9. How many digits are there? That would be 10 digits. Okay, so it's got to be followed by 4 digits. The first digit cannot be 0 though. So in our first digit position, there's only 9 options because there are 10 total digits, but that one can't be 0. Okay, it says digits can be repeated. So if I pick a 1 to go in this position, I can also have a 1 in this position. So how many options would there be for blank 2 of my digits? I'd have 10 because it can be anything 0 to 9, even whatever this is because it can be repeated. And what about our third digit? There'd also be 10 possibilities because the digits can be repeated, it can be a 0, there's no restrictions, and our fourth digit would also be 10. Now all I've done is kind of set up a list. So in our first blank there's 26 options, second blank there's 25, third there's 9, so on and so forth. The question is, what do I do with these numbers to answer the final question? How many different license plates are possible? Okay, now for the sake of this video, I'm going to tell you, and we can talk about in class why that is, but you're always going to multiply these numbers together to figure out how many options there are. And what I want you to do at home is figure out why. Why multiply? Why not add? Why not do something completely different than what I'm doing? Why do I multiply the amount of possibilities? When right now what I want you to do is plug this in your calculator and see how many license plates there are possible. I went and did that in my calculator and got, let's see, oh, that's a lot of zeros, 5,850,000. Yeah, that sounds about right. 850, I say 850. Yeah, with 3 zeros. That's a whole lot of license plates possible from that given constraints. But it's kind of cool because then people can say, like, these should be the restrictions on license plates to make sure we have enough license plates to go around. Maybe I need less restrictions so there can be more license plates, and the less restrictions, the more license plates you have. I don't know. People can start counting things like that. Okay, this college one I'm going to leave for you to do on your own, and we're going to go ahead and do the 5-letter word one. Okay, so how many 5-letter words can be made from using the English alphabet? So this is a permutation because order matters. If I put the words, I don't know, let's say put the word math, that's going to be a totally different word than if I rearrange the letters to look like this. So order does matter for a word that you're making. So if it's going to be a 5-letter word, that means each letter has a certain amount of options. So I have 5 letters, so I draw 5 blanks. Now I want to see how many different letter options I have for each blank. So if we're talking letters, there's again 26 options. So in position 1, so this is like the first letter of the word, I would have 26 different things I can put there. Now it says they don't have to be English words, so I don't have to worry about like, well, this probably isn't a word. We're not going to take care of that for now. We just want to see how many possibilities there are. So all it says is how many words can be made using the English alphabet. So technically, without any constraints, I could just have this as a letter or as a word, right? I know it doesn't make an English word, but technically you're arranging a bunch of letters, so that makes a word. So we're considering that. So that means I'd have 26 options for the second blank as well, because it does not say I can't repeat letters. So I have 26 options for all the blanks. And all you would have to do to figure out the answer to this question is go ahead and multiply those, which you can do on your own. Whereas this problem is very similar. So you're talking about a 5-letter word. That means there's 5 positions, 1 for each letter. Again, not necessarily English words, but it says you can only use each letter once. So if I have 26 options for the first blank, how many would I have for the second blank? So let's say my first letter is M. If I pick an M, then I can't use an M again here. So that would remove one option, so there would only be 25. The next one would be 24. The next one would be 23. The next one would be 22. Because let's say I use an A here, now you've eliminated 2 things that you can use from this blank. So 26 minus 2 would give you 24. And if I use a T here, then I can't use a T here, so I've eliminated 3 options, which is where I got 23 and 22. So you see the difference between those problems. So that brings up a really good point. There are 2 different kinds of permutation. One is where repetition is allowed, and one is where repetition is not allowed. Okay, so this is an example where repetition is okay, this is an example where it's not, and you see the differences in the calculations. And it's really important to consider that because they will have slightly different, I guess you could say, formulas for each. We don't really talk about formulas in these, I just talk about process. Now, the rest of this we're going to talk about in class, but basically you already know this, it's just kind of put formulas to it. One thing I do want to say before this video ends is what this means. The way you say this is not n exclamation point, it's n factorial. And you're not saying n, like really excited, it's n factorial. And what a factorial is, I'm going to give you the textbook definition, it's the product of all positive integers. I'm going to abbreviate that with plus sign, positive integers, less than or equal to n. I don't know why I didn't abbreviate this. Less than or equal to n. So for example, if I said 6 factorial, that would mean 6 times 5 times 4 times 3 times 2 times 1. Or if I said 10 factorial, it would be 10, 9, 8, 7, 6. You see what I'm saying. So it's a product, so you're multiplying, of all positive integers. These are all positive integers, less than or equal to n. So 6 is like your n, and then you want all the numbers less than that. That's what a factorial is. Which you can see where that might come up in a problem such as this, and knowing what a factorial is might help us derive a formula such as this in class. What I want you to also try on your own is this algebra application. So now that I defined what a factorial is, can you simplify this? It looks kind of ugly, but see what you can come up with. And I don't recommend multiplying it all out. That's my hint. But otherwise, that's what a permutation is. It's a way of counting things and a way of figuring out how many different options there are for a given situation. So remember, permutation, P, think position, order does matter. Otherwise, come with questions and have a good rest of your night.